Welcome back. Today we're thinking about probabilities, and in particular we're thinking about the probabilities of this dice. What I'm going to do is I'm going to roll the dice and then I'm going to cover it up before I see what it is. Without looking at the dice, it's impossible to know what number it is, but we do have some idea. For example, we know the number has to be between 1 and 6. We know it can't be a 7 or a 0 or a 1/2. In fact, there are only 6 numbers that it could be, and all those numbers have the same probability. This is what we call a random variable. A random variable is a value within an experiment that can take on different values, and each of those values have a given probability. So, for example, the number showing on the face of a dice would be considered a random variable because it can take on any number from 1 to 6, and each of those numbers have a given probability associated with it. Once we've defined a random variable, we often move on to define the probability distribution function. Notice we call this a function, and in mathematics, functions always have inputs and outputs. The input of a probability distribution is the value in the experiment. The output is the probability of that value occurring. For example, with the dice, one probability is that you roll the number 1. And the probability of rolling the number 1 is simply 1/6. And so we would assign to that number the number 1/6. Similarly, all the other numbers are also assigned a value of 1/6 because each number has the same probability. Now we can write a function in lots of different ways, and what we usually do is we'll write a function in terms of a table. And so I'll make a table, and on the left-hand side I'll write an x. That represents the value of the random variable. On the right-hand side I'm going to put p of x, which means the probability that that value occurs. And so for this example, I have the numbers 1 through 6 on the left-hand side, and on the right, since each probability is 1/6, I just have 1/6 assigned to each number. Now it turns out there are two different types of random variables. The first is called a discrete random variable. And a discrete random variable is a random variable that can take on only a countable number of values. When you see this word countable, this is a really fancy math word that we work really hard to define, but for most practical purposes, countable means a finite number. For example, a dice would be a discrete random variable since there's only 6 possible values that can come out. But I could compare this to a continuous random variable, which can take on an uncountable number of values. Think of something like the height of a person. Notice the height of a person can be any height. You can be 5'7" to 5'8", or any number in between, 5'7½", 5'7" and 1/57th. There's all sorts of values that can fall in between, and since it can take an uncountable number of values, we call it a continuous random variable. Let's compare that example to the example of rolling 2 dice. If I roll both dice and cover them both up, then I now could have any number between 2 and 12. But a difference between this example and the last one is that those numbers aren't all equally likely. We saw before, the numbers like 6, 7, and 8 are a lot more common than numbers like 2 and 12. So to make sense of the random variable from this problem, we need to consider all 36 possible outcomes of the 2 dice, just like we did in class. And so just like in the previous problem, I'm going to start by trying to write down a table and put all possible values from the random variable on the left-hand side of the table. Notice this table is going to have the numbers 2 through 12, since those are the only possible numbers that the 2 dice can sum to. And just like before, I've labeled my 2 sides as x and the probability of x. And now as I consider the probabilities of each of these values, I have to look at my possible dice combinations. And so what's the probability of x being 2? Turns out that probability is the probability of rolling a 1/1. And since there's only one way to roll a 2, my probability is just going to be 1 out of 36. Similarly, I can look at the number of ways I can roll a 3, and you'll notice there are 2 ways. I can roll a 1/2 and a 2/1. So my probability of rolling a 3 is 2 out of 36. As I continue going, my probability of rolling as 4 is 3 out of 36, since there are 3 ways to make a 4, and there are 4 ways to make a 5, etc., etc. And so as I move through the table, I simply count how many ways there are to roll each number, and I put that result into my probability distribution function table. Okay, so now that we have our table, we are able to look at it and see all the possible results that can come from this random variable. And probability distribution functions are really useful for helping us think about and know what's going on in a problem. The next step we're going to take is that of finding mean and standard deviation of a probability distribution function. And to do that, let's move back to our original problem where we had 6 dice and 6 possible outcomes. Now you'll notice this table looks an awful lot like the frequency tables we had earlier in the semester, except instead of x and p of x, we would have labeled this with our value on the left and our relative frequency on the right. And you see, if we think about it in this way, then this table looks just like the relative frequency table that we created earlier. And if you remember, we had a method for finding the mean and the standard deviation once we found the relative frequency. The way we found the mean was to use a weighted mean. A weighted mean is simply found by taking each value of x and multiplying it by its associated probability. The weighted mean could be given by this fancy formula: the sum of x times the probability of x for each value. So if I do that for these numbers, I'll notice I get 1 times 1/6 plus 2 times 1/6, 3 times 1/6, all the way until we get to 6 times 1/6. And then if I continue on, plug this in a calculator or do it in my head, then I get the final result, which is 3.5. That tells me that if I roll the dice, what's my average result? 3.5 is my average result. This is an interesting result because notice 3.5 is not one of the possible values. So your average value doesn't have to be one of the possible values. Instead, it is telling us what we would get if we were to roll the dice many times and average all of the results. Now, just like earlier in the semester, the standard deviation is more complicated, but the formula is going to be pretty similar to the formula we had earlier in the semester. I'm going to write it like this. It's the sum of x minus mu squared times the probability of x. It's just like earlier in the semester, we're subtracting the average from the value, squaring those values, and then multiplying by the probabilities. Multiplying by the probabilities serves the same purpose as what we did earlier in the semester when we found the average, or divided by n. However, for us this semester, we're not going to spend time doing this by hand. We're going to let our calculators do this calculation for us. So once we've completed this problem, let's move to the 2 dice example, and let's see if we can find the mean. Why don't you, before I calculate it, try to find the mean yourself and see if you can come up with the same number that I have. Did you get it? This is the value that I got. So there you go. That's a really quick introduction of what a probability distribution function is and how we think about random variables, and importantly, how we can use these functions to make sense of some problems. Now, if we get to class, we're going to work with more probability distribution functions, and importantly, we're going to move on and start talking about continuous probability distribution functions, which adds a little bit of a wrinkle to the problem. All right, see you then.